Problem number 14, a bunch of things going on in this problem. I give you 5 points. I ask you to do a bunch of things with them. So let's just do them one at a time. So the first thing we have m is the 0.43, -1. N is the 0.74, -3. We're asked to find an expression for the parametric equation for the line that contains these points. So how to parameterize a line is we need a point and a direction vector. So to find a direction vector, we can just do the coordinates of n minus the coordinates of m. So 7 minus 4 is 3, 4 minus 3 is 1, -3 minus -1 is -2. And so L of t is 4, 3, -1 plus t. So the point there plus t times the direction vector 3, 1, -2. This is our parameterization of a line. In part B, we are being asked to find an equation for the plane that contains A, B, and C. So A is the point 0, 0, 1. B is the point 1, 0, -1. C is the point 3, 2, 0. How do we go from 3 points to a plane? Equation of a plane requires a point and a normal vector. So the idea here is that we're going to take, so here is A, here is B, here is C, and we're going to say, okay, this is some vector W1, this is some vector W2, and then we're going to take the cross product of W1 and W2 to get a normal vector. Like here's our plane, we're going to find a normal vector that is orthogonal to both W1 and W2. How do we do this? So W1 here, direction vector from A to B, it's going to be 1, 0, -2. W2, a direction vector from A to C, is going to be 3, 2, -1. And so then, in order to find the normal vector, we take the cross product of W1 and W2. So I hat, J hat, K hat, 1, 0, -2, 3, 2, -1. I'm just going to skip steps and write down the final answer here for -5 and 2 after you take the cross product here. Quick check. Let's make sure that our normal vector is indeed orthogonal to W1, W2. 1 times 4 is 4, plus 0 minus 4 gives us 0. That's good. 12 minus 10 minus 2 is also 0. That checks out. That is good. Okay, so we've got our normal vector, and then we can pick any one of these 3 points. I'm just going to pick point A here. So it's going to be 4 times, 4 is coming from here, times x minus 0. Plus, I guess, minus 5 times y minus 0. And plus 2 times z minus 1 gives us 0. If we want to slightly simplify this, this is just 4x minus 5y plus 2 times z minus 1 is equal to 0. Thing for you to check at home, if we plug in b and c into this equation, we should get 0. Everything should check. It should satisfy the equation. I'll do b real quick. I'll let you do c by yourself. 4 times 1 minus 5 times 0 plus 2 times -1 minus 1. 4 minus 0 minus 4 does give us 0. That checks out. Okay, so that is part A and part B. Part C says find the coordinates of the intersection of L and the plane P. So what do we do? So let me rewrite L of t here. is going to be 4 plus 3t, comma, 3 plus t, comma, negative 1 minus 2t. What we're going to do is that we're going to plop in x is 4 plus 3t, y is 3 plus t, z is negative 1 minus 2t. We're going to plop that into this equation down here. What do we get when we do that? 4 times, so this is going to be 4 times x, where x is 4 plus 3t. Then we have minus 5y, where y is 3 plus t. Then plus 2 times z minus 1, or z is this expression up here. Negative 1 minus 2t minus 1 is equal to 0. So we have this equation to solve for t. The left side simplifies down to 3t minus 3 is equal to 0. And so the solution here is this is satisfied when t is equal to 1. So t is equal to 1 is not our final answer, but we need to plug in 1 into L of t. L of 1 is going to be 7, 4, negative 3. So this point is on, so 7, 4, negative 3 is on the line. Let's just check here to make sure it is in fact on our plane. Let's plop that into this equation right here. 4 times 7 minus 5 times 4 plus 2 times negative 3 minus 1 is 28 minus 20, and this is negative 8. And so yes, we get 0, so that checks out. There's one final part of this problem. Find a cosine angle theta at vertex A of the triangle. So what we have to do is, so once again, A, B, C. Here is theta. We call this vector W1 and this W2. Cosine of theta is going to be W1 dot W2 divided by the length of W1 times the length of W2, where W1 and W2 are as given here. So the length of W1 is going to be square root 5. That's the square root of 1 squared plus 0 squared plus negative 2, quantity squared. The magnitude of W2 is going to be square root of 14. W1 dot W2 is going to be 3 plus 0 plus 2 is 5. So cosine theta is going to be 5 over square root 5 times square root 14. I mean, you can simplify that to 5 over square root 70 if you want, but this is a place where it's fine to just leave it like this.